This is lesson 3.2, and in this lesson we will be learning how to solve systems of equations by graphing. So to go over your warm-up, the first question, you're supposed to solve each system by graphing, and so we're going to graph each of these equations. We've got a linear equation and we have got an exponential equation. So for the linear equation, my slope is -3 and my y-intercept is 9. And so it's going to be graphed like so. Okay, for the second equation, because it's an exponential equation, and I can tell that by looking at the exponent right there, and so because of that I know that my initial value is 12, and I know that this is decay and it's going to go down by half every time, so I can just use that to graph it. And so I would start at 12, and then I go down to half of 12, which is 6, and then I go down to half of 6, which is 3. And so that's how I know how to graph that one. Also, please notice on this that the scale on the x-axis is 0.5, so you have to go over 2 squares to make it one whole. Okay, for the second question, we've got a system of equations. I notice that they're both linear, and the first one is ready to graph. The second one, though, I'm going to have to solve it for y before I'm able to graph it, so that's just kind of my game plan for that. So the first equation, my y-intercept is 1. My slope is -1/2, and so that's my line. For the second equation, I need to solve it for y, and so I'm going to start by dividing by -4, and I have to divide everything by -4, and so it cancels right there. And then 2 divided by -4, that's where I get the -1/2, and 4 divided by -4, that's where I get the -1. So when I go to cancel that, or when I go to graph that, it's going to be a parallel line, just going to be moved down a little bit. Instead of being intercept at +1, it will be an intercept at -1. And so because of that, the conclusion is there is no solution. So there's no solution to that system. For number 3, I look at both of these equations. I'm going to have to solve both of them for y. I'm going to have to get that y by itself. I'm going to have to get that y by itself. So for the first equation, I'm going to start out by taking my finger, cover up the y. I'm going to get rid of that -3x. So to do that, I'm going to add 3x to both sides. So I get 2y equals 3x minus 10. Then I will divide everything by 2. So 3 divided by 2 and 10 divided by 2. And then I'm going to graph that line. So -5 is my y-intercept. I'm going to go up 3 and over 2. For my next equation, I'm going to have to subtract 10 from both sides. And I get 2y equals 3x minus 10 and then divide everything by 2. And this starts to look familiar because that's exactly the same equation. So when I go to graph that, I'm actually going to be graphing the same exact line. So the question is, where is the solution to that system? Well, the solution is every point on this line. And so this is where we're going to say there's an infinite number of solutions. And that's what you would say for your answer. Okay, number 4. We need to show whether or not this ordered pair is a solution to the system. And so remember that to be a solution to the system, it has to be true when I plug into that equation and also when I plug into that equation. So it'll have to be true for both of those. So what I'm going to do is I'm going to set it up. I just rewrote the first equation, 4x minus 2y equals 16, but I put parentheses wherever I'm going to plug something in. And then y equals 2 to the x. So what I'm going to do is I'm going to take my x, which is 5, and I'm going to put it right in there, and I'm going to put it right there, because that's where the x's go. And then I'm going to take y, which is 2, and I'm going to put it right there, and right there. And then I'm going to see if those equations are true. So the first one, 4 times 5 is 20, minus 2 times 2, that's 4. So 20 minus 4, that is in fact 16, and so it's true for that one. Then I look at the second one. Is 2 equal to 2 to the 5th power? Well, 2 to the 5th power is actually not equal to 2, it's actually equal to 32. And so since that's not the same, then this is not a solution. 5/2 is not a solution to the system. It can be on one of the lines, but it's not where they intersect. Okay, for number 5, we're going to do the same thing. So I'm going to take this x and y, the 0 and -2, and I'm going to plug it in. So I'm setting everything up so I can plug in my x and plug in my y. So I just rewrote these equations. I just rewrote them with the parentheses instead of the x and the y. So what I'm going to do is I'm going to say 0 for the x and -2 for the y. And now I'm going to see if they're true. So 5 times 0, -3 times -2, that's true. 2 times 0, 5 times negative 2, that's also true. So because both of those are true, this is a solution. 0, negative 2 is a solution, and that's where those two lines will intersect when we graph them. Okay, so in the lesson, we are going to practice using graphing equations to solve systems that are story problems. So the first problem, the Lamoureux family is traveling 725 miles to San Diego. So that would be how many miles they have left when they start. So that would be our beginning. So at the beginning of the problem. And so we also know that as the y-intercept. So if I was going to put this on my graph, they're going to start at 725 miles away from San Diego. Now think about this. As they drive, are they going to get closer to San Diego, so they're going to have fewer miles left to go? Or are they going to get further away from San Diego? Well, they're going to get closer. And so like if they drive for a couple of hours, well, let's just say 1 hour, they're going to go from having 725 miles, they're only going to be 650 miles because they're going 75 miles an hour. So what does that tell me about the slope of that line? It tells me it's going to be a negative slope. Okay, so it says that they're driving an average rate of 75 miles per hour. So my slope is going to be negative 75. And so the reason why I chose to say negative 75 is because of what it's doing. And so sometimes it really helps to think about the situation before you make an equation, because if I would have just said 75, then that would make my line go up like they were getting further and further away from San Diego. Okay, so write an equation to represent the number of miles left. So y is the number of miles that they have left, and negative 75 times 1 or times 2 or times 5, however many hours they're going, that's my x, and then plus 725. So let's try this. What if I said, okay, they're going to drive for 4 hours? Then I would do negative 75 times 4 plus 725. So you can pause this video and put that in your calculator and see what you get and see if that makes sense. Okay, so if you did that and you put it in your calculator, you would see that after 4 hours, they were going to be at 375. And that makes sense because they're getting closer and closer to San Diego. And so the question is, as you extend this, how many hours is it going to take for them to get to San Diego? Sorry, my line isn't straight. It's kind of hard to do a straight line on this. But how many hours will it take them to get to San Diego? So I'm going to let you do that on your paper with a straight edge, and then you'll have a better idea. So I'm just going to kind of, do some dash lines there. So then the second part of this question, the Christensen family is also driving to San Diego, but they live closer, so they don't have to drive so far. So they only have 575 miles to travel. So what does that tell us about them? It tells us that they're going to start right there. Now they're going to drive 50 miles per hour, so they're driving slower. So if they drive for 1 hour, they're only 50 miles closer than from when they began. And if they drive another hour, they're only 50 miles closer. So you can see that that's going to mean that they're going to maybe get there after the Lamoureux. We'll have to see how that goes, but that's going to be going something like that. So we're going to see what happens there, but how do I write the equation for that? So just like what I did with the Lamoureux family, my y-intercept is going to be the 575 because that's where they are when they start. The 50 miles per hour, again, I'm going to say that that's negative because they're getting closer to their destination and the line is going down. So my equation is going to be y equals negative 50x plus 575. And so get your straight edge and go ahead and graph this line. And so once you've graphed both lines, and I apologize that mine aren't able to come out quite so straight, but you're going to see something like that. So then the question number 5, it says, after how many hours are the two families the same distance from San Diego? So looking at our graph, when in hours are they the same distance away? So the y-axis, that's my distance. When are they the same? And so I look for where they intersect. So can you find on your graph, I'm just going to make a really big spot right there. Can you find on your graph where they intersect or where they're at the same spot? And I'm just kind of doing it like that because my graph isn't very good. But you can look at that. So if you did this right, you should see that they should have the same distance to go when they have traveled for 6 hours and they have 275 miles left to go. So if they wanted to meet, that would be where they're going to meet. Now, if they keep driving at the same rate, who's going to reach San Diego first? So if you look at your graph, and again, mine's not very good, But you can kind of see that the Lamoureux family, even though they had further to drive, they're going to get there first. So how long will it take them to get there? It's going to take them about 10 hours. And how long does it take the Christensen family? And so if you look at your graph, it should be about 12 hours. Now that's not exact, okay, but it's pretty close. And so we can say that in answer to the question, who would reach San Diego first? We can say that the Lamoureux family will reach San Diego first. And then how long will it take them to get to San Diego? So we can say about 10 hours. And it says round to the nearest tenth of an hour. So I think about 10 hours. That may not be good enough. So since I have to round to the nearest tenth of an hour, how could I use the equation to help me find the exact answer? So my equation for the Lamoureux family, remember, was this. And so what I want to know is when is the miles left to go 0? Meaning, when do they get there? And so you can actually find the answer to that question by solving that equation for x. So you can pause this video and solve that equation for x. And when you get that, x will tell you exactly how many hours they have to drive to get there. Okay, so when you solve this equation, you should have got 9.6 repeating. And so that's 9 2/3 hour. That is not 9 hours and 66 minutes, because if you think about that, 66 minutes is more than another hour, so that doesn't make any sense. But 2/3 of an hour, if you think about on a clock, okay, you've got, there's the 12 and the 6. So this would be half an hour. 2/3 of an hour, if you split it up into 3, it's going to be right there. So it's going to be 40 minutes. So 9 hours and 40 minutes would be how long it will take them to get there. And that's, now if it says to the nearest tenth of an hour, then I'm actually fine if you wanted to put 9.7 hours, because that is to the nearest tenth. But if you say 9.6, that's not the same thing. You can say 9 hours and 40 minutes, that's fine. But that would be how you would tell. You could use the same strategy to find out when the Christensens will get there. You can see it's going to be about 12 hours, but you could use the same strategy with their equation to find out exactly how long.